negative, 0, and then undefined. So undefined. So the 4 types of slope. Now what this means is when we're on a graph from left to right. So you always want to read the graph left to right. So when you read the graph left to right, and we'll do some practice with this and just identifying what type of slope it is, and then identifying and actually finding the slope, what number it is. So up here, what slope is, what it is, it's the constant rate of change. Now, this is printed in black and white versus color, so you might have to rewrite this. We use the letter M to represent slope. So this is known as slope. Anyone, because this is the stuff that drives me crazy. I'm like, okay, the word is slope. Where did the M come from? Anyone have any idea? Is M? Okay, are any of you in French? Let me see. Is anybody in French? You can unmute or chat. Okay. They believe, now this is not proven, but they believe it's from the, oh, someone just sent a chat. Oh, okay. So Victoria says she used to do French. So they believe the M stands for Montier. I think it's Montier. Oh, I don't know if I spelled that right. I think it's E-I-R. If someone can look that up for me, that'd be great. Montier, which means to climb. Oh, I don't know if that's spelled right, but it means to climb in French. So they believe that's where the slope, the M, came from. It was never proven, but that's what they believe. And I'm like, good enough for me. Sounds good. Now, ways to describe slope on a graph. Now, slope, what it is, it's the rise over the run, meaning how did the change in Y? Now, this little symbol here looks like a triangle. Does anyone know the Greek letters on what that symbol's called?
I don't know what it's called, but I know what it represents.
Okay. And what does it represent?
Change.
Good. It's a change. It's called the delta. So whenever you see delta Y, so this symbol, this is called delta. And it means the change. Oops, I just crossed it out. It means the change in. So this is the change in Y over the change of X. Again, mathematicians, we don't like to write tons of stuff out. So we use a lot of symbols. So when you ever see this, the change in Y over change of X, that means how did the Y value change over the X value? Okay. Now, so we have the rise or the run. This is like a negative slope from left to right. If it's going downhill, it's a negative. If it's going left to right, if it's going uphill, it's positive. We also talk about the vertical change over the horizontal change. That's your Y and that's your X. So this is your Y and that's your X. Okay. So 4 types of slope. All right. So now we're going to look at how to find slope on a graph. Okay. Okay. So we're going to look at the back. Okay. So how to find the slope or the rate of change on a graph. We want to do, let's check the chat. Oh, Montier. Oh, M-O-N-T-E-R. Oh, yeah. I didn't think about that if they had a French virtual class. That's probably why. That's probably why no one's taken it this year. So M-O-N-T-E-R. No I. Thank you. All right, so we're going to graph. So we're going to look at number 1. When you do this, oh, dang it, I just lost my. You want to find the points on the graph. Quick. Choose any points that don't hit a corner. So choose 2 O's. Choose 2 points that hit a corner, that hit a corner of like the graph. So like you're looking at, like these have the points, which is nice. Maybe like right here. So you want to choose 2 points that hit a corner. Okay. Then what I like to do is if I can, I just make a triangle. Like these 2 points already told us. So then I go, I go up. So you're going to end up making a triangle. Okay. So you're going to make a triangle. And then you're going to count rise over run. You're going to count the rise over the run, or the vertical change over the horizontal change. Okay. And then you can decide, okay, you can add then if it's a negative or a positive. Then add positive, you don't have to do the sign, but add the positive or negative sign, and simplify if needed. So finding the slope of each of these graphs, I'm trying to just judge my getting all. Okay, just by looking at this graph, and if it's going like this, what type of slope is this?
Zero.
Good. This is just a flat line like this is 0, which means the rise or the run, if we just pick any 2 points, it has not gone up at all. So it's a 0 over. Now you can say, well, if I had that point and this point, it doesn't even matter which 2 points. Because if, let's say it's 0 over, what is that, 4 and 8, what's that, 12? That would equal 0. So any flat line like that, any horizontal line, the slope is 0. And you can write 0 like that, or just write in the word 0. Okay, now this one, left to right, from left to right, is this going uphill or downhill?
Up.
Good, it's going up. That means it's going to be a positive slope. So I don't even worry about the signs. I just go, okay, so I know it's going to be positive. Now, how far up do we go and how far over? If that's, okay, so that's, we're looking at the y values. So that's a -3, -3, and it went up to 4. So -3 up to 4 is 7, and it's going up and over. Sorry, my nose is running. Okay, then the run. How far over is it going? It's at 2 to 5. Good. So it's going over to over thirds. Now, here's the deal with slope. Don't change it. Don't change it to an improper fraction. Leave it as 7/3, because this is one thing I forgot to tell you. It's a ratio. It's a ratio of the change in y over the change of x. So leave it 7/3. Do not change this to 2 and change it to 2. So a ratio is written as a fraction. Okay? That's one of the ways you can write a ratio. Okay, now this one, just by looking at it, is this a negative or positive? Good. It's like left to right, it's going downhill. So right then, I go ahead and put a negative so I don't forget. It's a negative. Now, this is where I'm going to zoom in a little bit so I can figure out where this line crosses. So here's one that goes in the corner. And it looks like there's another one right there. So there's 2. Now, since it's linear, it doesn't matter which 2, here's another one it looks like. It doesn't matter which sheets that we find the slope from. It's linear. I just wouldn't do it. We can't guarantee this one. I think it is, but I can't guarantee it. So what you want to do is you want to make sure that you can do rise over run. So I make the triangle. So how far did I go down? Looks like 2. And then over 1, 2, 3. So your slope is going to be a -2/3. Okay. Now we can even do this. We can go up to here and over 3 there. That's fine. So it's going up 2 over 3, down 2 over 3. It doesn't matter. all the points. I can even go down 4 and over 6, but it'll simplify down to 2/3. So from a slope on a graph, it's all about just counting. And first of all, recognizing, is it a positive or negative slope? And then just counting how far up, how far over. Okay. Okay, now let's look at from a table. How do we find it from a table? How do we find slope and rate range from a table? Well, the only thing is the table, those are ordered pairs from a graph. I would not spend your time graphing it, but this is where we can find the same thing. Slope is the change. So you want to do the change in y, which is that delta y over the change in x. Oops. So we have the change in y over the change in x. We first determine, remember how we were determining if it was linear? So notice this had +3, +3, +3, +3. These 20 to 14, that's going down by 6, down by 6, down by 6. That's showing it's linear, but now for slope, we want to do the change. We want the -6 over 3. So -6 divided by 3, can we simplify that? Because -6 divided by 3, we can simplify this and just make it a -2. So the slope of this graph is going to be a -2. Now, anytime you see a slope of a -2, that means it's going maybe down 2 over 1 or up 2 and over 1. Okay. Let's look at our table. Now, the x, that like is adding 2, adding 2. What do we notice about the y's? Oops.
They stay the same.
They stay the same. But for this then, what's happening is it's the change in y over the x. You put 0 over 2. What's 0 over 2? Or 0 divided by 2? This would be 0. Because if you plotted these, that would be like a negative, that'd be a -1, 2, 1, 2, 3, 2. It's turning out to be a 0 slope. Okay. Now, so all the y's were the same there. Okay. All right. Now, looking at this one, what do you notice about this table? That's adding 3, that's adding 6, that's adding 3. What do you notice about the x values?
They stay the same.
They all stay the same. Now this is saying like 3 over 0. Do you know what 3 divided by 0 will give you?
0.
Okay. Actually, be very careful. So I'm going to show you guys something. This is saying like 3 divided by 0. If I said 6 divided by 2, that 6 would go inside, right? And 6 divided by 2 is 3. You're saying 3 times 2 is 6. Okay. If I said 9 divided by 3, 3 times 3 is 9. This one, 3 divided by 0. What times 0 gives you 3? Is there anything times 0 that gives you 3? Okay, this is what we call undefined. Undefined. That worst curse word in algebra. So undefined. Because if you graphed these, you're saying -3, 6, -3, 9, -3, -3. You're drawing an undefined slope. So when the x's are the same, it's an undefined slope. Is that a function? Nope. No. So when the 0 is in the denominator, when it's under the fraction